Hello viewers, welcome back to another section of this multivariable calculus tutorial. In this video, we are going to solve a problem on line integral. We solved one problem in our previous tutorial where we integrated over a line segment. In this video, we are going to integrate over a circle. So a circular segment. Make sure you watch this video to the end and don't miss any portion of it. Show me some love by subscribing and also pressing the subscription button there. So evaluate on the region C of x squared y squared dx, where C is a circle centered at the origin of radius 2 and centered on the y-axis at y equals 4. Now you ask yourself, what do I need to compute my line integral? The first thing that should come in mind is your parameterization. We are supposed to convert our x and y into t. Once we are dealing with circle, you know that in the polar region, our x is simply equal to r cos t and y is simply equal to r sin t, right? Then you're going to have the necessary conversion. So in the polar region, that is cylindrical, so you're going to have your z to be your z. Yes, let me add that one to it. So how do we convert that? Now, we say the circle has a radius of 2, meaning I'm going to take my r out. But let's see something. Let's analyze the diagram. So you realize that when we consider the diagram, we're going to have our circle spinning around y is equal to 4. So therefore, when we are parameterizing it, we are going to have our x to be equal to 2 cos t, our y will be equal to 4, and our z will simply be equal to the 2 sin t. So at this point, we move to finding our ds, where dx is simply equal to the square root of what? My x prime of t, y prime of t, and z prime of t. So my x prime of t is simply going to give me negative 2 sin t, then I'll get all of them squared. Then all this plus, this will give me 0, this will give me 2 cos t all squared. Alright, so at this point, the next thing I'm going to do here is I'm going to further simplify this, and it's going to give me 4 sin squared t plus 4 cos squared t. Where I factorize sin squared 4 out, I'm going to get sin squared plus cos squared to be 1. So square root of 4 is equal to 2, and that becomes my ds. So I simply go back to my function and make the necessary substitution. But what would be the region over which I am going to integrate? Is simply 0 less than or equal to t less than or equal to 2 pi, since I'm doing it over a circular region. So I'm going to have my integral 0 to 2 pi, then my x 2 cos t all squared multiplying my y squared, that is 4 squared, my ds will come as 2 dt. So at this point, I'm simply going to get 4 cos squared t multiplying 16 multiplying 2 dt. So with what I'm having here, I'm going to get 64. I'm simply going to get 64 cos squared t multiplying 2 dt. And take note, when you are integrating trig functions and you have a cos squared, you make sure you break it down into the cos ax or cos bx form. So with this, I'm simply going to convert this into the 1 plus 2, so integral 0 to 2 pi 64 open bracket half of, now what will be cos squared t? See something, cos 2 theta is simply equal to cos squared theta minus sine squared theta, right? So once you have this and you want to make this a subject, you make sure you make substitution for this, and this is the same as 1 minus cos squared theta. So I'm going to get cos squared theta minus 1 plus cos squared theta. So therefore I can simply say that this my cos 2 theta, so my cos 2 theta is simply equal to, cos squared theta, my cos squared theta is simply equal to cos 2 theta plus 1 everything over 2. So therefore here I'm going to get half out, then what is inside here is going to be 1 plus cos 2 theta multiplying 2, and that 2 will simply cancel this out, so that I get my integral 0 to 2 pi of 64 multiplying 1 plus cos 2 theta. Now at this point, I think our integration becomes so simple. Sorry, it's t with respect to t. So we can move forward to simplifying this. Then you know, if you integrate this, what are you getting? This alone is going to give us 64 out. So you can take 64t 0 to 2 pi, then plus 0 to 2 pi of cos 2t. So when you integrate cos 2t dt, this is simply equal to negative 1 over 2 sine 2t 0 to 2 pi. So in totality I'm going to get, so at this point you realize that the 64 was multiplying everything inside. So at this point I'll factorize the 64 out back again, and I'm going to get my t plus half sine 2t, and everything 0 to 2 pi, right? So what is sine 360? So I'm going to get, for the first part, 2 pi plus sine 2. So I'm going to get sine 2 times 2 pi, so sine 4 times, and that is giving me, so sine 4 times 180 is 0. This place will be 0, minus this will be 0 plus 0. So the answer is simply 2 pi multiplying 64, that is 128 pi. Thank you for joining this class, and don't forget to subscribe, like, and share.